Okay, so the first chunk we're going to do today is the graphing quadratic equations. Okay, so quadratic is an equation that contains an x squared. Okay, so the first question says, what are the transformations? So I'm looking for words. So there's 3 items here that are going to happen. So if I times by 2, what happens to the shape of my parabola? Do you remember? It would get more narrow, right? It would look, the arms of it. So this would be normal, but then, right, I would get more narrow. And then I shift to the which direction 3? To the left. And 5, I would have to go down. Do you notice how this one's opposite in the bracket? Remember that? Okay, question 2, I'm looking for 2 answers here. So the negative multiplier does a flip. So the parabola would look like that. And the 1 inside the brackets will move into the which direction? Right. Question 2, we're going to do a whole shebang here. This is kind of like the next 2 questions is a big page on your test worth 16 points or something. Okay, so the vertex is positive 4, opposite. I have to move to the right 4. And negative 1. Okay, because it's over there, I could have also have moved it to the back end here, which would say negative 1, right? It doesn't matter where it is, you just have to ask yourself that. Slope, that's the multiplier. So negative 2 is the slope. So what does that already tell me about this shape? It's going to be flipped like that, and it's going to be also narrower, skinnier. Domain, this is supposed to be your free point. Every parabola does what left and what to the right? Negative infinity to positive infinity. If you wrote me that the other way around, positive infinity to negative infinity, which sometimes happens, you would get that wrong, right? Because it's like reading a book. You have to do it in an order, left to right. Okay, range, I'm going to draw that little picture for myself again, showing the heights go from what low to what high, down to up. So the down, we're going negative infinity to the top height of -1 with a square, inclusive, right? Okay, the axis of symmetry is when I can cut it in half like that. And how do you make a vertical line? How do you, no matter what, how do you make a vertical line? What should I do? X equals. Okay, if I do horizontal lines, that's a y equals, right? But vertical is x. And what x value are you going to cut right through? The vertex, right? I'm going to go right through that vertex coordinate where I'm at a 4. And the y-intercept, what's the idea of every y-intercept? What's going on? X is the 0 value. So I'm going to do that and figure out. So y plus 1 equals -2, 0 subtract 4 squared. Okay, please do some BEDMAS stuff. Brackets, -4. Exponents, what's -4 squared? +16, right? Do you guys remember all that with -4 squared versus -4 squared, right? Which one do I want? I want that. This is not the same. If you're in your calculator, that's not the same thing. Times -2. So I'm at -32. And I still have to subtract 1. Okay, I did a little over-up chart here for you. What is just normal? 1, 1, 2, 4, 3, 9. Should we leave it like that, or do we have something different going on our pattern? We got something different. Why? Because the slope is -2, so what is that multiplier going to multiply? The pattern. The pattern is multiplied by -2. So I'm going to go to my vertex for -1. I'm going to go over 1, down 2. Over 2, down 8. Please ask yourself, does your y-intercept make sense? Do you remember we were supposed to cross down here at -33? Does that look correct? Yeah. Okay. Often on the exam, I'll get somebody who graphs it correctly, and then they've told me something like, my y-intercept is +5. Look at your graph. Does that make sense? No. Right? It's going to continue, and it's going to cross way down here. On your exam, I'm going to look for 5 coordinates. See how that has 5 coordinates? I'm looking for arrows. You did get a deduction if you forget an arrow. And the other question, doing the same questions, but this time my equation looks different. Okay, what do you do to get the vertex of this style? -b over 2a, comma, plug in number. Okay, so what is the opposite of my b value? +6 over 2 times -1. Okay, now we're going to plug it in. So we have to be very careful here. You're going to do this. What is the negative of -3 squared? So do you see how I did that? What's the negative of -3 squared? That's the part that often tricks people right there. Okay, the slope is the multiplier, so how many x squareds would you have? -1. So what does that tell me? It's going to open downward again. the axis of symmetry is cutting it in half. You must have an x equals on there, or that's going to be a deduction. And which x value should I go right through? -3. You guys, why did I do -2 on the other one? That isn't a -2, is it? Oh no, never mind, sorry. Yeah, it is. I was looking all of a sudden here now. Sorry, I'm all good. Domain, range. So the range, what's the lowest to the highest? -infinity low to the top height. So we're going to get to a 2 up top, square, bracket. Your y-intercept, boom, got it. What is it? -7. Okay, it's easy because if you put a 0 in, gone, gone, -7, right? Okay, so here's my vertex, -3, 2. And our pattern, we're -1 as a slope, so we are going to go 1 over, 1 down. 1, 1, but down, right? We're going to go 2, and then 2 and 4, but down. Okay, that's all I'm expecting, 5 coordinates. You do know this, you know the y-intercept, right? As well. So -7 makes sense on the y-intercept. Okay, I'm making some equations. So here's what I was told. I had a vertex and then I had some other point. So therefore, my vertex, that's what it would look like. Because if this is a vertex and this is a point, you have to connect them. That makes sense? Vertex is either something that's on the top or the bottom. Okay, so now I'm going to think about this. What have I done? How did I get there? So I would have had to go over 2. I'd have to move over to the right 2, and I'd have to go up 8. Right, that's how I got there. Let's look at our typical. Is that on my typical? No, that's not typical. So let's look at this position where when I go over 2, I should only go up 4. But I didn't do 4, I did 8. Therefore, I've had a multiplier of 2. So you're going to make an equation using a slope and a vertex. So I'm going to give you two options. You could do it in this form. You could do it in this form, or you could have had the number at the end. I believe you're gonna have those on your formula sheet. So on your exam, you get that sheet that I gave you at the start of the year. So look at here. This is what I have. This one is opposite and this one is same, right? This one is opposite and this one is opposite there. The vertex is opposite and same, but on this it's opposites, right? That's why I put that little note for myself. If you use that, everything is opposite. If you use that, opposite but same. Okay, you get this exact paper from me on your exam, all right? Okay, on this question, I knew the x-intercepts. Okay, tell me, how do we always get x-intercepts? What's our strategies we usually use? We usually do factoring, right? We've usually done a factoring system and then we get an x-intercept. So what if I give you the x-intercepts? Can you work backwards? Okay, so if I had this as an x-intercept, this would have been my process before. I would have done an x subtract 5 in brackets and an x plus 4 in brackets. And how do I reverse factoring? What's the opposite thing of factoring? Foiling. Foiling, factoring, opposites. So if I FOIL this, I get x squared minus x minus 20. And what should I now write officially on the equals there? I should write y. Okay? Here it was 0 because that's how you get an x-intercept. You have to turn y into 0. Okay, so you know that process. Foiling, factoring, opposites. Okay, complete the square time. Okay, so step 1. Move that out of there. Step 1, get rid of the end. Why? Because you want to make your own trinomial. How do I create that perfect trinomial? Do you remember the two little details? Half squared. Remember that? Half squared. What's half of this? Divide by 2 is 1. And what's 1 squared? 1. Okay. Now you have to remember that that just wasn't there. So my teeter-totter, not good. I'm going to bounce it back out. So I'm going to do the same on the other side. So y subtract 4 equals a perfect square. So what would FOIL to that trinomial? What multiplies to that and adds to that? What times what is 1? And 1 plus 1 is 2, right? So this, when I say multiplies, it squares. And when I say add, it actually doubles, right? Okay, so here we go again. Y subtract 30. Okay, I am not going to complete the trinomial here. Why can I not do the trinomial stuff right now? Because it is a complex trinomial. You can't do that. You need to do it with a simple trinomial. So what am I going to do to make this just start with an x squared? I'm going to pull the 2 out of it. Okay? And you should know, because look at the format of this. What's going on? If there's a number multiplier, it has to be out. Right? Where is it? It's out of that bracket part. Okay, so now what's my trinomial going to start with? If I took the 2 out of this, that's x squared. What happens to this though? If I took the 2 out, minus 8x. Okay, now this is where I get to make my own trinomial. Half, and you're looking at this guy right here, the minus 8. Take half of it and square it. Get a 16. Half squared. Okay, I'm going to bounce this teeter-totter back out because that's something I just created. It wasn't there. I threw it on. What are you going to bounce it out with? And your answer is not 16. So how much do I need to put onto the other side to create the bounce back? 32. So this is going to go y plus 2 equals 2 brackets perfect square. So I'm going to have to put an x because that's x times x. What multiplies to 16 and adds to negative 8? Negative 4.